So in this video, I'm going to discuss how you know when to use GCF and when you don't. So every time you go to factor a question, the first thing you should always try is factoring with the greatest common factor, right? If there is something that's common between every term in the equation, then you can take out a GCF, okay? So between these three, there's nothing common, 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 and nothing common, okay? On the back of this page, we see that X is common between both, X is common between both, X is common between both, negative 3X is common between both. So some people put 3X as the GCF, but if you can take a negative out, you should. You should never leave your X squared as being negative. So if you can take negative 3 out to leave the X squared, that's what you would do. So negative 3X is the GCF here. Here it's negative 7X, that's the GCF. 2 is the GCF. It's not X because there's no X with the 4. X is your GCF. X is your GCF. No GCFs here. 4 is your GCF. No GCFs. No GCFs. None. None. And 4. So you always try to take out a greatest common factor, if there is one, between the terms. Once you have the GCF taken out, you need to put the remainder in the bracket. So for example, the remainder of what's left, when I take X out of each of these terms, the remainder is X plus 8. Now you could use the box method if you want, make a smaller box. Okay, so this goes in your box. Okay, X times X makes X squared. Now X times what makes 8X? It's 8. So my factors are X and X plus 8. Here, if I did the box, this has to be an X, this must be a negative 10. Negative 3X times X makes X the X squared. Negative times a positive makes a negative. X squared, 2 into this, 3X, 2 into that, 2. X. There's no GCF here. If you have 3 terms, your remainder should have 3 terms. Okay, so what we did was we went through, we found all of the questions that had GCFs and we factored them out. The next thing you want to do is, even if you use GCF to factor, your remainder might also be factorable. Okay, so what you want to look at is what you have in brackets after you took the GCF out. Can that be factored even farther using the box method that we used before? So X plus 8, no, we can't factor that further. That can't be, neither can this or this. This can though, okay? So bring the 2 down. This trinomial, if I did a box with just this trinomial, I'd have X squared, I'm only talking about the stuff that's in the brackets here. Multiplies to give 2, but adds to give me 3. Right, that's 2 and 1, so. You can't forget to bring the 2 down, okay? Because the only way that you can multiply these two brackets together to get back to the answers if you also multiply them by 2. So this is the factored version, this last line. Okay, now if you want to find your x-intercepts, you would set this bracket and this bracket equal to 0. You don't need to set this equal to 0 because that wouldn't make sense. 2 equals 0. There's nothing to solve for here. You only set the brackets that have x in them equal to 0. So you'd set x equal to 0, x minus 20 equal to 0. Same here. Okay, this question there was no GCF for, so it must mean we can just use our box method to figure out. Okay, it looks like our factors are x plus 5, x minus 3, has to add to give me 2. Okay, x minus 3, x plus 5. Now, this one I took the GCF out of. Look at the remainder. Are there two numbers that multiply to give me 4 but add to give me 5? Yeah, it's 4 and 1. And you still have to bring down this 4 because it is a factor. Okay, so if I multiply all this out, multiply these two binomials out, and then multiply it by 4, I'd get back to this answer. Now, this is one of the special case box methods where our two diagonal terms canceled to make 0. That's why we have no, it's not a trinomial. We have no middle term here. It's because these guys canceled to make 0. So whatever multiplies to give me 1, they must be equal but opposite numbers because they also have to cancel to give me 0. Okay, so our factors are 5x plus 1, 5x minus 1. Multiplies to give me 4, but adds to give 4. 2 and 2. This is the difference of squares question. It's the one where the diagonals cancel each other. That's why I don't have a third term. Multiplies to give me 64, but adds to give me 16. 8 and 8. Now double check to see if your remainder can be factored further, and it can. Multiplies to give me 1, but adds to give me 2. Like that. Now if I was looking to solve for my x-intercepts, I would set x plus 1 equal to 0. And I'm going to get the same answer for this, so I don't need to do it twice. So I have two x-intercepts that are both going to be -1, 0. What that means, -1, 0, if that's the x-intercept and it's the same place twice, it must mean that my graph is coming down and touching this and going up. So the vertex is right on here.